In my last video, I explained the propagation of errors in the case of multiplication and division. In this video, I am going to explain propagation of error in the case of product of two physical quantities. A and B are two physical quantities. Delta A and delta B are the errors in the measurements of A and B respectively. Z is the product of A and B. Since there are errors in the measurement of A and B, in Z there will be an error. That error is delta Z. Measured value of A will be A plus or minus delta A. Measured value of B will be B plus or minus delta B. Then Z is the product of A and B, A into B. Z is equal to A into B. Then error in Z is delta Z. So Z plus or minus delta Z is equal to measured value of A into measured value of B. Then A into B, AB, then this with this plus or minus A delta B, then this with this plus or minus B delta A, then plus or minus delta A delta B. Then this expression, you divide this side by Z. So Z divided by Z is 1, then plus or minus delta Z by Z. This side fully you divide by AB. So when you divide this AB by AB, 1, then plus or minus. When you divide this term by AB, A will get cancelled. So dB by B plus or minus. When you divide this by AB, B will get cancelled. So delta A by A, then plus or minus delta A by A into delta B by B. Now this one and this one will get cancelled. Delta A by A is very small. Delta A by A is very small. Delta A is the error in the measurement of A. So this is very small. Similarly, this is also very small. So when you multiply these two, it is going to be very small. So this term can be neglected. Now delta Z by Z is equal to this one and this one are cancelled. So plus or minus, so that you take it outside. Then delta A by A plus delta B by B. So here delta Z by Z. So this is the error in the final result, delta Z. You are dividing by Z. So this is the fractional error in the product of two physical quantities. And this is the fractional error in A. This is the fractional error in B. So we can say fractional error in the maximum fractional error in the product of two physical quantities is equal to sum of the fractional errors in the individual quantities. Here there is an example to understand the propagation of errors in the case of product of two physical quantities. Length of a rectangle is given to be 5.7 plus or minus 0.1 centimeter. That means in the length there is an error of 0.1 centimeter. Breadth 3.4 plus or minus 0.2 centimeter. So in the measurement of breadth there is an error of 0.2 centimeter. We are using this value to find the area. In the area there will be an error. Area is equal to length into breadth. So area is equal to length is 5.7, breadth is 3.4 without error. Correct value is length into breadth. So 5.7 into 3.4. If you multiply, answer is 19.38. It can be written like this, 19.4 centimeter square. That's the correct value of the area. You know the fractional error in the product of two physical quantities is equal to sum of the fractional errors in the individual quantities. So we can calculate delta A by A. Delta A by A is equal to delta L by L plus delta B by B. So delta L is 0.1, length is 5.7. So this is the fractional error in the length. Similarly, fractional error in the breadth, 0.2 divided by 3.4. If you do this calculation, you will get this value. If you do this calculation, you will get this value. Add these two, so you will get this value. So you will get the fractional error in the measurement of in the calculation of area. So delta A by A is 0.0763. There's a fractional error in the area. So you can calculate the error in area. So delta A. So you rearrange this A will come here. So 0.0763 into A. Now area is 19.4. So if you multiply, you will get this 1.48. That is the error in the calculation of area using these values. So maximum error in the calculation of the area is 1.48. Now let us see the propagation of error in the case of division of two physical quantities. A and B are two physical quantities. In the measurement of A and B, there are errors delta A and delta B. Then we are dividing A by B. Then we are getting Z. In Z, there will be error. Error in Z is delta Z. So Z is A by B. But the measured value of A is A plus or minus delta A. Measured value of B is B plus or minus delta B. So Z plus or minus delta Z is A plus or minus delta A divided by B plus or minus delta B. Now this A can be taken outside. After that, 1 plus or minus delta A by A. Similarly, from this you take B outside, then inside 1 plus or minus delta B by B. Z plus or minus delta Z is equal to A by B, then this term. When this term is taken to the numerator, it can be written like this: 1 plus or minus delta B by B raised to minus 1. Then we can apply binomial theorem. When this x is very small, 1 plus x all raised to n is 1 plus nx. So that rule we can apply here. When this minus 1 is taken inside, this plus will become minus, minus will become plus. So as per this binomial approximation, 1 plus x all raised to n is 1 plus nx. This n is taken inside. Similarly, here we have taken this minus 1 inside. Then divide both sides by z. So when you divide this side by z is 1, then plus or minus delta z by z. When you divide this side by z, this z will get cancelled. So this z will get cancelled. So then this 1 into 1, 1. Next to this with this plus or minus delta A by A. Next multiply this term. So plus minus plus delta B by B. Then this with this, you are getting delta A by A into delta B by B. This one and this one will get cancelled. Delta A by A is very small. Then delta B by B is also very small. So when you multiply this, it is going to be very small. So this term can be neglected. Next, this plus or minus can be taken outside. maximum possible error. So here minus then plus, but here plus or minus, but when we take outside plus or minus taken outside, here it will be plus. So now this can be removed. So now delta z by z is equal to delta a by a plus delta b by b. So this is the fractional error in the quotient. This is the fractional error in the measurement of A. This is a fractional error in the measurement of B. So maximum fractional error in the quotient of two physical quantities is equal to the sum of the fractional error in the individual quantities. Now let us see an example. Voltage across a wire is given to be 10 plus or minus 5 volt. That means in the measurement of voltage there is a error of 5 that is measured by the voltmeter. Then current flowing through this wire is measured by this ammeter. Current is given to be 10 plus or minus 0.2 ampere. We are using these values to determine resistance of this wire. Then according to Ohm's law, V is equal to IR. After rearranging, R is equal to V by I. Correct value of the voltage is 100. Correct value of the current is 10. So 100 divided by 10 is 10. So that's a correct value of the resistance. But in the measurement of voltage and current, there is an error. So fractional error in the measurement of the resistance is equal to sum of the fractional error in the voltage and fractional error in the current. So delta R by R is equal to 5 by 100. Error in the measurement of the voltage is 5, then by V. V is 100. So 5 by 100 plus delta I is 0.2, then I is 10. So delta I by I. Now 5 divided by 100 is 0.05. 0.2 divided by 10 is 0.02. So when you add these two, you will get a 0.07. That's a fractional error in the measurement of resistance. Delta R by R is 0.07. So absolute error in the resistance is delta R. So you take this R. So 0.07 into R. So 0.07 into R. Our resistance is 10. So the absolute error in the measurement of the resistance is 0.7. Fractional error is 0.07. So the resistance will be equal to 10 plus or minus 0.7. The voltage, there is an error of 5. Current 0.2. In resistance it is 0.7. So resistance value is 10 plus or minus 0.7. I hope you have understood these concepts. Thank you for watching the video.